Hey guys, so we're going to cover section 6.3, which actually covers three different topics. And because of my internet, I'm going to go ahead and do each topic one at a time, video by video. So the first topic we're going to talk about are ratios. Now, most of us have seen ratios before. In fact, we did see it back in chapter 5 when we were looking at fractions. So a ratio, we typically want to think of as the concept of comparing two quantities. Two quantities. And it's important to note that those two quantities have the same units of measure. And that comparison typically can be written in three different ways: A to B, A colon B, or A over B. Now, when you write a ratio, though, it's kind of important to note that it might be you might have to kind of explore it a little bit in order to fully figure out a situation. So let me give you an example of what I mean. Let's say you were told that sorry, I'm looking for an example. There we go. The ratio of boys to girls in a class is 2 to 3. Okay, so let's explore what that means. And we're going to try to write 4 separate statements about what this means. Now, visually, what this means is that when we're saying the ratio of boys to girls is 2 to 3, that means if you have 2 boys, here, I'm going to switch my colors here, and they switched me over to the new whiteboard again. So, okay, thank you. I don't need that anymore. So let's say we have 2 boys right here. Oops. So those are 2 boys and then 3 girls. All right. So that's the ratio that we're looking at. So there are a few different statements we can make. And like I said, we're going to try to do 4 separate statements about this. So one statement that we could make is that 2/5 of the class consists of boys. Oops. Another thing we could say then, if we're talking about it kind of in that terms, that would mean that 3/5 of the class consists of girls. So kind of notice how we kind of jumped to using 5 in our fraction. That's because what we're talking about is the total. So when you write the initial ratio, you understand that when you say 2 to 3, that 2 is 2 boys for every 3 girls. So even though that fraction works to represent this ratio, as does the colon, okay, when you're talking about mathematically, you're really actually saying that in a breakdown, we have 5 total people we're referring to then, 2 of them being boys, 3 of them being girls. Okay, that's one way of comparing them. We could say, we can kind of compare the boys to girls in general. So kind of coming back to the 2/3 relationship in the initial ratio, we could say that the number of boys in the class, that's supposed to be an in the class, is 2/3 the number of girls. So that's using the original ratio in a statement. Now, if I wanted to do it the reverse, if I wanted to compare girls to the boys, I could see that I'd have an extra girl compared to the boys. So this would be a comparison of two girls to two boys. That's 1-to-1, right? And then an extra girl. So it's like a 50% increase. So it's technically the reverse fraction of 2/3. So the girls, the number of girls in the class is 3/2 or 1.5 the number of boys. Oops, sad 3/2 or 1.5 the number of boys. So it's the reciprocal, literally, of the ratio comparison when we do it for girls. Okay, so those are kind of the ways we think about ratios. We could kind of do these comparisons with the total number of children versus the actual ratio itself that we are given. Now, I do want to kind of note that when we were kind of looking at this particular example, this 2-to-3 relationship, that doesn't mean the class is only 5 kids, right? This class could actually be, let's say 20 kids or something like that. So if I was interested in kind of seeing it as a bigger class, I could kind of grow my ratio for that. So a 2/3 relationship, here, I'm going to draw them as separate little squares here. So those 2 boys, 2-to-3 relationship, and then 3 girls. We could grow that as many times as we need to see the total class. So this would be a class of 10. And now it's a class of 15. And then what I just said a second ago, a class of 20 would be this one. So we have 20 students in this class. And in this 20 student class, our ratio has grown to be 8-to-12. But 8/12, if we think of it as a fraction, does in fact reduce to 2/3. So it kind of plays this same building process of fractions, but broken up, we're seeing it as 2/3 is repeated over and over and over again, the 2-to-3 ratio, until we can build up to the 8/12, or vice versa. We could have the 8/12 be our comparison, and notice that that's the same thing as saying 2/3. All right. Okay, now ratios lead right into the concept of rate, and they are very similar. The difference with ratio versus rate, a rate has a comparison between quantities that have a different unit of measurement. So compares quantities with different units of measurement. So let me give an example for this. Let's say Nevada. Oh, sorry. Let me get to my pen here, the right pen color. Let me choose blue, please. Thank you. Example. Okay, go away. Nevada has 500 vehicles per 1,000 people. So what we're comparing in this is vehicles and people. 500 to 1,000, which reduces to 1/2. So we could say then that when we're talking about a rate, we're saying that it's 1 vehicle per 2 people. We could reduce it that low. All right. But the idea is it wouldn't make sense to write this without the units of measurements attached. So when you write this rate, you want to say you're talking about 500 vehicles for every 1,000 people. That's not how you spell vehicles, by the way. Let me fix that. It's just lagging behind. But if I wanted to do it in the reverse, the reduced mode, okay, the 1 to 2, you could say it's 1 vehicle per 2 people. Wow, it's still not wanting to write nicely. I'm sorry. Vehicle per 2 people. Or you could say it in reverse, 2 people per 1 vehicle. That would work as well. But you do need to include the units of measurement in order for it to truly make sense. Now we use rates all the time. Like we have a rate when we talk about miles per gallon. That is literally an example of a rate. So if you say my car is, or let's say car, my car gets 37 miles per gallon, you know that means that for every 1 mile traveled, I'm sorry, every 1 gallon of gasoline, you would get 37 miles traveled in that car. Oh, I hate this stupid whiteboard. I switched to the new one again. For every 1 gallon of gas, the car can travel 37 miles. And of course, I know that there's differences versus highway and roads when you're starting and stopping all the time, but yeah, we kind of had that understanding. But what both of these really lead to, the really useful thing, is proportions, because proportions allows us to start doing some serious applications. Now, a proportion sets 2 ratios. Oops, that's not the 2 I'm referring to. 2 ratios or 2 rates equal. So it means that we would have some sort of statement like this. And that is actually really useful information. So let me give you an example of where a proportion can be really useful to us. Blue pen. Here, I'm going to switch the red pen to green because it makes sense. All right, blue pen again. Okay, blue pen. So let's say if the ratio in a school of teachers to students is 18 to 1, and there are 360 students, how many teachers are there? So what I can do is create a proportion of this information. The first piece of information I'm given that I can compare for every 1 teacher, there's 18 students. Oh, I wrote this backward. That's so funny. I wrote that backwards. That should be 1 to 18. Teachers to students. One teacher for 18 students, not 18 teachers for one student. I'm so sorry. Wow. Okay, if the ratio in a school of teachers to students is 1 to 18, and there are 360 students, how many teachers are there? Wow. Okay. So the idea is I can use the first ratio I'm given, the 1 to 18, write it as a fraction. And then I can use the second piece of information I'm given, the fact that in the school, there are 360 students total. So if down here in the bottom is the students, right? This is students. And this is teachers. Then I would need to put the 360 students right there. And I don't know how many teachers there are, but I'll go ahead and call it X. And you might remember that when we have two fractions equal to each other, the way we could solve them is cross multiply. So I'm going to cross multiply. And that's going to give me, so the 1 times 360 is what I get along the first multiplication, which is 360. The second multiplication is 18 times x, which I can just write 18x. And now I have a simple little equation that I can solve by dividing both sides by 18. And if you grab your calculator, and I recommend doing that, and divide, that'll give us 20. So 20 teachers. Okay, so let's look at another example. This one was using ratios because we were comparing people to each other. Let's do one with rates. Let's say, if 4.8 pounds of flour costs $8.40. Wow, that's expensive flour. How much will 6 pounds cost? So now we're looking at rates. Okay, and we could set this up as 2 rates. The first would be knowing that 4.8 pounds, and here I'm going to shorthand notation, there's the pounds, LBS, over $8.40 is going to equal, the other piece of information we were given is 6 pounds. So I'm going to put that at the top, just like the other side. And then I don't know how much that costs. And again, I've set up 2 fractions equal to each other so I can cross multiply. Now I'm going to drop the units while I do this cross multiplication, but my answer X is going to be dollars. So 4.8 times the X is just going to be 4.8X. Oops, sorry, my screen is lagging really badly. 4.8x, there we go, equals, and then 8.4 times 6. Actually, let me calculate that really quick. I don't know that one. Times 6 is 50.4. 50.4. And then I'll be able to solve this little equation by dividing both sides by 4.8. And that gives me 10.5, which in dollars would be $10.50. That's how I'd want to write that. And there you go. So these ratios and rates are useful when we're able to actually solve things.